Okay, so today we are looking at an introduction to 3D geometry, and our goal for the students today is to be able to calculate and interpret distances and midpoints in 2 and 3 dimensions. So our first problem we're asked to do today is we've got this little problem. The points A and B are on the diameter of a circle, coordinates given. Find the coordinates of the center of the circle. So typically, if you're faced with a problem and it's unfamiliar to you, if you're faced with a problem and it's unfamiliar to you, the best strategy to start solving the problem is to try and sketch it. So this type of a problem, the best problem-solving strategies is make a sketch of the information that we're given. So we're given some information here, and we have a circle drawn in some coordinate axes. We have if I just draw some coordinate axes like this, we can plot the point -3, 5. That's going to be something like this, maybe. This is the point A. And then we have the point B, which is 0, 7 up here. This is the point B. So this is the diameter of a circle, and we're asked to find the midpoint here. And asked to find this point here. So what you need to in order to solve this problem, you need to understand that on a circle like this one, if this is the diameter of the circle, then the center of the circle is the midpoint along this line. So the key thing in solving this problem is to realize that you're after the midpoint. So at that point you need the midpoint formula. So if you look at the formula sheet I put on your desk, you should be able to open up the formula book. You can also find it in the Google Classroom anytime you want here. This is our formula booklet. And topic 3 is geometry, and at the start of topic 3, there's a page of prior learning knowledge. Things you're expected to know before starting this course. This is the prior learning. And obvious things like area of a parallelogram, area of a trapezoid, things like that. But you also find down here some things you'll have seen from coordinate geometry in last year's course. And if we look at these ones, you can see the distance formula in 2D and the midpoint formula. So the midpoint formula here on this one, when you add two numbers together and you divide by 2, you're finding the average of those two numbers. This is simply a variant of the mean formula. When we find the mean of a set of numbers, you add the numbers up and divide by the number of numbers. So you're finding the mean of two numbers here. You're finding the mean of this one, you're finding the mean of this one. So make sure when you do this and you write this one up, that you use the correct notation because we've got a bracket in it, it's a coordinate point. So what we want to do is the center of the circle, which would be the midpoint, I'm going to call midpoint M, is equal to x1 plus x2. So it doesn't matter which one you call x1 and x2, it's not going to matter. We've got 0 minus 3 over 2, which is 2x values. And then we've got 7 plus 5 over 2. That's going to give us -3 over 2, comma, that's 12, 6. There's our answer.
Is it okay if I call my number decimal?
Yes. Yes. As we talk about, answers on this course can be given in exact form. So -3 over 2 is the exact form of this number. That can also be given as -1.5. That's an exact form. Or they can be rounded to 3 significant figures if they are an estimate of a number. But this number can easily be expressed in exact form in both forms. They will always be accepted, whether it's the correct decimal or the correct fraction. So let's have a look at question 2. Question 2 is basically going to be a variant on this one. So find the value of x if the midpoint is given and the midpoint is given between points A and B. So let's just put everything into the formula. Let's put everything into the formula. We have got two x values. So we've got x1, which I'll have as x, and we'll have x2 as -1. We add them together, divide by 2. We take these two in the same order. We've got 5 plus 10 divided by 2, which has to equal the midpoint, which is -3, 1.5. So we get this equation. From this we can expand. We know that x minus 1 over 2 has to be the -3. The other bit we don't necessarily need. So this implies the equation x minus 1 over 2 is equal to -3. We can solve that any way you like. It's a fairly simple one, but pop up n solve. Try on n solve on this one. So on my calculator, I'm going to start to clean it up. So that's my equation. We press menu, algebra, n solve. Into n solve we put the equation, so control, divide, we've got x minus 1 over 2 is equal to -3. And we have to press comma to say solve this for the variable x. And then it will tell us our answer is -5. So this implies that x equals -5. No, it's secret. Secret. Alright, so we're going to do a little bit of investigation, work together in your teams on each of your tables, and have a go, see if we can figure out any of the answers to these questions here. Okay, so we got our rock climber, we got us some coordinates. How many meters above the horizontal plane would the midpoint M be? Well, directly above the horizontal plane is this direction here, and this is 400 meters. So if you're only halfway up, you're only half as high, so this distance here is going to be 200 meters. How would you find the coordinates of the midpoint of N between R and S? So what we've basically done here is we found the average of the distance from this point to this point. 200 would be the average of the distance, so that should work in each of the dimensions. So we can, for question 2, I'll squeeze it in here. We've got 60 plus 0 over 2. We've got 80 plus 0 over 2. And then we've got 400 plus 0 over 2. That's going to give us 30, 40, 200. That's the coordinates of the midpoint here. So the last two are basically, well, what is this formula? This formula is going to be x1 plus x2 over 2, y1 plus y2 over 2, and we need a new letter. So we use z1 plus z2 over 2, and we get our 3 coordinates. So we have our x-axis is the one coming out of the page, the y-axis goes across, and the z-axis goes vertically, creating a 3-dimensional space. And we can see this relates to the formula that we just used for the midpoint in 2 dimensions by adding an extra dimension. You can find this on the formula booklet. If you turn the page now from prior learning into, so we were there on prior learning. Here it's actually, we don't turn the page, it's just right below. Here is the coordinates in 3 dimensions. Here is the distance formula in 3 dimensions. So it has an extra dimension. Right. We're going to have a go now at trying to sketch on a 2D page something 3-dimensional. So it's a little bit tricky here on this one. So you need your grid lines on this one. You'll not be able to do it without square paper. As you're told clearly, you need to have a square paper notebook for things like this. If you don't have a square paper notebook, you can't do it. You'll find it really, really difficult to do online. So we're going to have a go at drawing this. So we're told the vertices of the base have the following coordinates for a three-dimensional cuboid. So we start off here with the origin. This is the origin here at 0, 0. So our first point A is at a distance of 4 on this one. I'm going to do my Z. I'm going to put my coordinate axes. So here is my y-axis. I'll do my z-axis. I'll do my z-axis coming in this direction. Sorry, my x-axis coming in this direction. And then my vertical z-axis going up in this direction. So these are my coordinate axes. If I count along the x one, the number of diagonals, we've got 1, 2, 3, 4. So this here would be point A. One, two, three, 4. Yes, point A. Point B is down here, so I'm going to do point C first. It's a little bit easier. You see here? We go 1, 2, 3, 4, 5. We go 5 across. We can put it here. Here's point C. So this one has to be a square, so that means that this line is also going to be moving in this direction, and it's going to be going down 4. 1, 2, 3, 4. And then this one will come horizontally across, and we get a rectangular base in 3 dimensions. So this would give us point B, which is at 4, 5, 0. So now we have to do the coordinates A1, B, which are mirror images of this rectangle. So we have to take this rectangle and we're going to mirror it upwards in this direction. Does it tell us? It doesn't tell us the coordinates of anything on the top, but we can work it out from this part here. That the cuboid has the dimensions 4, 5, 2. Well, this length here was 4, and this length here was 5, so this length here is 5, and this length here is 4. So the z direction has to be this length here of 2. So if we go up by 2, we can go to here, we get this point here. This would be O0, sorry, O1. This one would go 2 up. This one would go 2 up, this one would go 2 up, and then we can join those points, and we have our cuboid drawing. There's our cuboid. So the coordinates of these different points, this one is going to be 0, 0, 2. C was at 5, 0, 0. No, it wasn't. It was at 0, 5, 0. So this one is going to be at 0, 5, 2. B is here, so this one, B prime or B1, is going to be at 4, 5, 2.
So how do you know which way to go with the
So the first digit is the x direction, which is this axis coming out of the page. The second digit is the y, which is in this direction. The third digit is the z, this direction. What are the coordinates of this point here, A1. Discuss with the person next to you. What's the coordinates of this point? What's the coordinates of A? What's the coordinates of A? What's the coordinates of A? It's written there at the top.
4, 0, 0.
4, 0, 0.
Yeah.
Yeah? So if we move that vertically up by 2, what will the new coordinate of A1 be?
4, 0,
4, 0, 2. Okay, so have a go at, what time is it?
Dear. Okay.
Let's have a look at, so we found the coordinates, we need to do B. Determine the coordinates of the midpoint M on the diagonal AC1. So A is down here in the bottom corner, and C1 is this point here. So we have a diagonal up through the shape like this, and we need to find the coordinates of this midpoint here. So we can use the formula for the midpoint, which is going to be, we need each set of coordinates. So A is at 0, no, sorry, A is at 4, 0, 0. And C is at 0, 5, 2. So the average between 4 and 0, so we need 0 plus 4 over 2. We need 0 plus 5 over 2. And we need 0 plus 2 over 2. That's going to give us 2, 2.5, 1. This will give us the midpoint. I have an interesting question or two. Let's have an interesting question. If I find the midpoint of the diagonal from, let's say, this point here down to that point there, would they be the same midpoint? Yes. So it would be the same midpoint taking any opposing vertices of the cuboid. Hope you guys at the back are following what I just explained. So we also need to, what are we doing? Explain whether they're the same midpoint? Yeah. Okay. So we can move on with these questions now. Okay, so for A, we're just putting it into the midpoint formula. We've got 4 minus 1.5 over 2, and we've got negative 3 plus 5 over 2. This is going to give us, let me take the calculator for this one. So you can always use the calculator here. It becomes a little bit tricky, so I put my quotient symbol. I put 4, subtract.
Sorry, I think you're doing the midpoint. It asks for a distance.
Is it? Ooh. Thanks. I'm not reading the question. I've been on midpoint almost. Okay. I got a little bit stuck there in my tram tracks, heading in the same direction. We got a distance to calculate now, and we have the distance formula on the formula sheet. So what we want to do for the distance formula is, the distance formula is d is equal to root x2 minus x1 squared plus y2 minus y1 squared. This is the 2d one. We can put our formula into this one. This is going to give us 4 plus 1.5 squared going to give us -3 minus 5 squared. I'll put that into the distance formula. Pull it up onto the calculator. So we want square root, bracket, bracket, 4 plus 1.5, close bracket squared, plus, close bracket, -3 minus 5, close bracket squared. Just double check that what I've entered into the calculator is what I was hoping to enter into the calculator, and it will give me my answer. So this one is, what's that going to be to 3 significant figures? It says 9.0824.
1.71.
9.71, excellent. That's going to give me 9.71.
So I'm pretty
If
sure
you're
that, sorry, excuse me.
Yeah.
I'm pretty sure that's not the answer as well, because you kept 1.5 since you divided it by 2, and it's -3. So basically it's 4 minus -3. Oh, no, I'm not sure why I have 1.5 in the first one.
No, that's right.
Because I'm subtracting -1.5. Which means I'm adding 1.5.
Oh yeah, that's my bad.
Yeah. If we wanted to just check the 3 significant figures, and just for the sake of the video, when you're watching it through, I'll show you how we can change the settings. So document 7.2, we take it to the document settings. I can switch to float 3. If I press enter on this one now, it will give me the 3 significant figures at that time. Document's correct. So then we want to try it in 3 dimensions. So 3 dimensions, same as the midpoint formula, we just extend by 1 more. So we add the difference between the z values into the formula. So our distance in AB so we want the absolute value of AB. That's the distance. Put this one in. So I will have my x2's as b for this one. So -4 minus 1 squared. 0 minus -2 will be +2 squared. And 3 minus 1. 3 minus 1 squared. Hop these onto the calculator. Shift square root. -4 minus 1, oops, this is my bracket. Bracket, -4 minus 1, close bracket squared, plus 0 plus 2, I'm going to do in my head. 2 squared, and the last one was 3 minus 1 squared. You don't have to type it in, you can do the arithmetic in your head if you want. This is going to be 2, 3 minus 1, you don't have to type that in, but I'm just showing you how to do it. We type it all in, whoops, press enter, and we get root 33. This is an exact answer, so we can answer it like this. If we wish to have a decimal approximation, we press Control Enter, we get 5.74.
So, there's 3 minus
So
10.
it's 3 minus 10 and this one, 3 minus 1.
I've got the Monday blues in there. 3 minus 10 squared. That's going to give us a different answer. So if I've made a mistake, I scroll up like this one, and then press enter. It will copy that one down for me and go in and edit the number. I'll have to type all this out again. I can add in the 0 that I missed here, back enter, and I get root 78. So this is exact answer, root 78, approximate answer. You don't need the approximate answer, as said previously. You can give your answer as an exact answer, so root 78 is the best form of calculator. It will always simplify it to the best third here for you. And then we can press Control Enter, and we get 8.83. Okay, last question for us. Have a go at this one, work together in your pairs. So we need to find the maximum length of a garden tool that can fit in the box. So a tool that drops into the box, the longest it can be is the length of the diagonal. So we need to find the length of the diagonal. We can either find the length RB. I'm going to find the length O to A. I'm going to find the length O to A because at the origin, all of the coordinates are 0. So the difference between them makes it really easy. So I can just use the coordinates of A for that one. So our distance is going to be 4 plus 9 plus 16. So we've got 4 plus 9 plus 16. Root 29.
So did you get the 60?
2 squared is 4, 3 squared is 9, 4 squared is 16. And obviously 2 minus 0 is 2, 3 minus 0 is 3, 4 minus 0 is 5, so it's that one. C, we need to find the height of the storage box. So the height of the storage box would be any of these lengths here in this vertical direction. So if we go from the origin to F, we can see that that one is going to be 0, 0, 4. So the height of the storage box is 4. Or H, for height. Okay, lastly, we need to find the angle between the diagonal BR and BQ. So this is drawn a right angled triangle here. You can see in green here, we found the length. This one is root 29 of that one. We found the length of this one, this is 4. We can find this length here as well in order to use use trigonometry. This is a right angled triangle that is sort of placed on the box like this, and we have got to visualize that one. We need to find this length here, or we can use the two lengths that we've got. So if we take that right angled triangle in D, and I sketch it, we know that this one is 4, we know that this one is root 29. This is the right angle, this is the point Q, turn it into a 2D, this is V, and this is R. Take a minute to visualize the shape and how I've turned it into a 2-dimensional shape using the vertices B, Q, and R. And we need to find the angle between these two diagonals, so that the BQ at the top and the BR. So it's asking us to find this angle here. Label our sides. So this one is going to be the opposite. This one is the hypotenuse. We can do a SOHCAHTOA. And we have the opposite in the hypotenuse, so we need the sine formula. This one tells us that the sine of theta is going to be the opposite over the hypotenuse. So the sine of theta is going to be 4 over root 29. That means theta is going to be arc sine of 4 over you the arc sine of 4 over root 29. Let's control enter, and we get 48 point. So what's happening here with the calculator? Is that lit? Oh,
There's more numbers going on.
what's the next digit?
0.
0. What's happening here when we see that decimal point there, this isn't 48. This is not an exact answer. This is an approximation. It's one fault of this calculator is that when it rounds like this is actually the number we want. This is the number that we want. This is, we can't have it expressed exactly, so we have to round it. You will get it wrong if you write, for a question like this one, 48. To 3 significant figures, this is 48.0. You can see the calculator doing this because it's not writing 48, it's writing 48 point. That decimal point doesn't normally appear. When it's appearing like this, when it's skipping right into 0, so this one would give 48.0 degrees, like this. Okay, have a go at exercise 4A and 4B, the password, finish it off by homework.